right, so we're going to look at statistics. Like I said, it's quite a large topic, okay? It's kind of considered to be as big as calculus. However, it is in no way as difficult as calculus, I kind of think, okay? Because the majority of it you'll be able to do on your calculator. The majority of the statistics type questions are in paper 2, so you'll be able to use your calculator. You can do a lot of this stuff without the calculator, but it's just very time consuming, which is why IB don't want you having to do that, okay? They'd rather you show a wide range of skills rather than just working out one particular statistics question, which could take forever. Does that kind of make sense? Now, there will be quite a few definitions that you are just going to need to learn, okay? And we will get those down, some of them down now, okay? So this type of thing, you just need to learn these definitions. So the first thing, quantitative data is to do with, what do we think? Quantities, yep, so to do with numbers, okay? So there's two different types of data that you can have. There's qualitative data. Qualitative data is to do with, it would be like if I was going to interview students to find out their reaction to uniforms, okay? So that's me getting their opinions about it. That's called qualitative data. I need to put my mask on. And then the other type of data is quantitative data, which is to do with numbers. So I would maybe, if I wanted to look at the heights of students or their math scores over the last 2 years, that would be quantitative data because it's to do with numbers, okay? But for the purposes of maths and what we're doing, it's all to do with quantitative, okay? And quantitative data can be either discrete or continuous. Have you heard of these terms before?
Yes, so discrete is when it's like can only be 1 or 2 or 3.
Yes.
Continuous, it can be just any value within it also.
Right, yes. Discrete data can only take particular values. So, for example, the number of pets a household has. Okay, you can have 1, 2, 3, 0, 5, 10 pets. You can't have 1.32 pets. Okay.
Oh wait, so sorry.
Yep.
Continuous. I thought continuous was like 1 to 3 pets, not 1 point. Like
no.
So it's not a range. Continuous
No.
is just so discrete is when it's just an integer.
Yep.
And continuous is just anything.
Yes.
It's separate.
Yes. So also discrete, the rolling of a dice. Yep.
Yeah.
Is discrete because it can only take the values 1, 2, 3, 4, 5, and 6.
Is a negative number discrete?
Yeah, could be. Yep. You could say if you're going to play a game and if you win the game, you get $5. If you lose the game, you owe me negative $2. Okay, so that would be discrete because it's either you get $5 or you lose negative $2. Make sense? Also, discrete can also be things like the colors of cars. I remember when I was at school, we had to go out for geography, I think it was, and write down the colors of cars that were going down a particular road, which I've never understood why. Okay, that's discrete as well, because it's either going to be red, blue, green, black, or whatever, okay? It takes particular values.
It's not quantitative.
Well, it kind of is quantitative because you would have your number of green cars. You'd have 10 green cars, 5 blue cars. You're not going to get 3.6 beige cars, okay? The other thing, okay, so the good way that I like to think about this, because sometimes I get confused, surprisingly. Discrete data is items that can be counted, okay? So if you can count it, it's discrete. Continuous data is not restricted to certain values. It can occupy any value within a given range. So for example, give me an example of continuous data. Height. Okay, because you might get somebody that's 1.3 meters, or you might get somebody that's 1.36 meters tall. Excuse me. Or the time it takes you to travel to school, it could be 1 hour, 36 minutes, and 42 seconds. Okay. And again, I like to think continuous data is items that can be measured, right? So continuous, something that can be measured. Discrete, something that can be counted. So they may give you some data and say, is this data discrete or continuous? And you will need to say it is discrete because it contains items that can be counted, or it's continuous because it can be measured. Okay, so you need to learn these definitions. All right. Also, okay. You will have heard of things like the population. Consists of every member in a particular group that you want to find out about. So the population of Summersfield students would be every single student within Summersfield. Okay. Population of Bermuda is every single person that lives in Bermuda. Yep. You okay, Nick? Yep. Okay. But sometimes it's difficult to get information from the population because the population can be very, very large. You know, if we're going to look at the population of Bermuda, that's 66,000 people roughly. And some people might be, you know, I don't want to participate, or it might be difficult to get hold of people. So instead of looking at populations, sometimes we have to take, yes, you've heard of samples and populations?
Yes.
Right, so a sample is a subset of the population that will give you information about the population as a whole. So if I wanted to look at, I wanted to survey Summersfield students about uniform, I might decide, well, rather than speak to every single student, I might take 10 students from each year group, and that will be my sample. All good? No, we're going pretty quick through this because I think this is all, like, you'll have heard these terms before. The next thing we need to look at is, okay, well, if I'm going to take a sample, I've just said I could take 10 students from each year group. That's one particular way I could do it. I could, why might that not be fair, actually?
Well, there's different ways to do it. It's like there's random, there's then, or you control it so you have like 10 boys, 10 girls. It was like different. I don't know what the names are, but there's like different ways to say it.
Yeah, there's different ways, but why? So I've just used an example. I'm going to take, if I want to take a sample of all Summersfield students, I'm going to take 10 from each year group. Why is that not fair?
Because some year groups have different numbers of people.
Good, because some year groups have different numbers of people. It's not going to be fair. Let's say that there's 100 M1 students, and I'm only taking a sample of 10 from them, whereas they're getting underrepresented. Whereas if there's 10 DP1 students, they're getting fully represented in what their views are. Okay, so it might not be fair. Yes, so it's different ways to take samples. Okay, and we need to know what these different ways are. There are 6 of them. Okay, and you need to be able to describe what the type of sample is, okay? So these are terms you need to learn, okay? So,
Like random and like controlled, like truly random.
truly random? Can you ever get truly random?
Yeah, only computers can, really.
Really?
Yeah.
You can definitely get truly.
No, you're not really. It's very extremely difficult to get completely random.
If I literally just chucked a dice, if someone handed me a dice and I didn't know how many sides were on it,
Yeah.
I didn't know the color of the dice, I didn't know anything about the dice.
Okay, so convenience sampling is the easiest method. My shift button doesn't work. You select members of the population which are most easily accessible. Okay, so if I wanted to do, for example, take a sample of DP students, I would sample U3 because it's most easily accessible. That would be a convenient sample. Okay, but again, it may not be very representative because
There's a reason why we're the most convenient. Then you're getting the 3 smartest students. Yeah.
three smartest?
Three
What?
mathematically
What?
better math.
Well, that's a good point. If I was going to do a survey about mathematics, and if I wanted to do a survey about how students enjoy mathematics, it would be not very good to use U3 as a sample because you love mathematics so much. Okay, but that could be my convenient, like it's a reasonable sample to use. Okay, a convenient sample. It will skew my data,
I was
but
gonna say that's probably what the media does.
yep, absolutely, yep.
Yeah.
Okay. So and that's why it's important to, if you're looking at studies, to see what kind of sampling they use, because it will affect the data big time.
How can you even find that? I've never seen a statistic where they say,
Yeah.
They should.
90% of whatever, gathered using the convenience sampling method.
They should state, and if they're not stating it, then alarm bells should be ringing. Okay, simple random sampling is the next one. Okay, so this is each member has an equal chance of being selected, i.e. names put in a hat and randomly pulled out. Okay, so if I wanted to, e.g., if I wanted to take a sample of 100 Summersfield students, I could put all the names in a hat and pick 100. Does that make sense? It's fairly straightforward, I think. Yep. Okay, good. Systematic sampling. Okay, so we list the members of the population and select a sample according to a random starting point and fixed interval. So e.g., if I wanted to create a systematic sample of 100 students at Summersfield, which has a population of, let's say, 1,000, even though it doesn't, we would choose every 10th person from the list. Okay, so we would list them all, and then we're kind of being more systematic about it. It's less kind of random, but we're just picking every 10th person along the list, okay?
Okay, well,
How
Make it a
do
whole
you line up the list?
Well, again, you could. Okay, so you could. All there's different ways you could do it completely random. You could do it by name. You could do it by age. Again, it's one of those things that it can be however you want.
I thought it meant like if you had 100 people and you wanted to pick 10, like you would get a random number from 1 to 100, and like say it was like 67. You start at person 67, and then you do every two.
You could do it like you could do it like that as well if you wanted.
This is a random starting point.
Yeah, because
Yeah, it doesn't necessarily matter where you start as long as you're kind of jumping. Picking every. Yeah.
But I feel like that only matters, right? The skipping a person if the way at which the members are listed isn't random, you know?
If it isn't random.
Yeah, because if it's randomly listed, like truly randomly listed, then you could just take a random 10 and it will be the same as skipping 10 because it's just
I guess.
You know? Like,
It depends how you want to list them then.
I guess yeah. So the whole point is how you list them.
Yeah.
All right. Next one. Done. Okay, stratified sampling. Okay, this involves dividing the population up into smaller groups known as strata. The strata are based on known interests or shared characteristics, such as
Gender,
age, race. Okay, so whatever, and then you put your random sample together from each strata. So the good thing about this one then is you're ensuring that different people from different groups are all being represented. Okay. So for example, if there was 1,000 students at Summersfield and 200 were male and 800 were female, okay, we would split them up and then we would take an even number of from each group, okay, and that way both male and female will be represented properly or fairly. Yep.
then that's used to like come to a conclusion. Like say, let's make it even more extreme. Say there's a
Okay, the last one is quota sampling. Okay, so this is like stratified. But involves taking a sample size, from the strata, which is in proportion to the population. So e.g. in a school of 1,000 students, %60 are female and 40% are male. Your sample will contain 60% female and 40% male. There's no perfect way to do sampling, okay? It depends on what you're trying to show. It depends on what you're trying to find out.
So you're trying to skew the data.
Yeah.
Because in all these methods, you can take the same data and come to a completely different
Exactly.
conclusion.
Yes, you could. Yep. That's why they say, what was it? Don't statistics is I can't remember what they say. There's a phrase about lying with statistics. But you need to know these 5 different ways, okay? So they may come up with a situation in the exam where it'll be like, this sample was taken, what kind of...
lie, but they don't tell the truth.
Yeah, something like that. But they will say, how was this, what kind of sampling has taken place, okay? And usually, it will be stratified or quota, okay? Because those are the ones that are kind of most interesting, okay? But it could be systematic or simple random, okay? Make sense? Mm-hmm. Okay, so you need to learn those. Right. I'm not going to look at that. Okay. So some basic things to do with stats. Measures of central tendency. What am I talking about when I talk about measures of central tendency? Any idea?
Like bell curve?
No.
The median.
Yeah. The median. What else?
The mode.
Yep. What else?
Mean.
Okay, the mean, the mode, and median. Okay. So.
Standard deviation?
No. So for a data set, the measure of central tendency tells us where the middle of a data set lies. The 3 measures we use are, so the first one, the mode. Now what's the mode?
Kind of
The most occurring value.
Yep.
Oh, yeah.
The value that occurs the most. The median is the...
Divine middle of the data set.
Yes.
Well, when they're all lined up.
Good, when they're all in order. Good, so the middle value of the data set when they are in order from smallest to largest. And then the third one, the mean, which is?
The sum of all of the data divided by how many data.
Right, so the sum of the data divided by the number of data points. Yeah. So you can see already, we can mess about with our sampling, kind of make our statistics tell us what we want. We can then also pick a measure of central tendency to make our data tell us what we want. Which is why it's really important if you do see any kind of research, you're kind of questioning it, because especially if you've got large corporations, so cigarette companies used to pay people, they'd pay people like researchers to do data, like to do analysis of the effects of smoking, okay? And they would want, obviously, them to show that smoking has got no harmful effects to people's health. Okay, and they did this and they showed it, okay? But obviously, they can manipulate the data, they can do whatever kind of sampling they want, they can pick whatever kind of measures of central tendency. So if you're looking at data, it's always important to look at, well, who is conducting this research, Okay, who is somebody getting paid to do it? If they're getting paid to do it, is it because, you know, that's also a kind of a telltale sign that it may be manipulated. Because if you're getting paid, you might not be as honest, I guess, as somebody who's doing it just to find out exactly what's going on. Does that kind of make a bit of sense? Okay. Let's actually put here. The mean is denoted by the symbol. I'm going to write it with my pen. So on the calculator and in the course, the mean is denoted by the symbol x, a little bar on top, okay? So we call that x bar.
So,
Um,
if I go into statistics and stuff.
Yeah, so let's we'll do an example using stats or using so let's say find the mean, mode, and median of the following data. So let's 3, 4, 7, 1, 13, 4, 2, 11, 9, 4, and 10. Now, I'm guessing you all know how to do this without a calculator, yeah? Mode is easy enough. The mean, you just add them up, divide by the number. The median, we would need to put them in order. Yep. And then locate the middle one. To do it on the calculator, we all use Inspires, don't we? Where's my Inspire? Here we go. Now, bear with me here because I am used to doing this with the TI-84. But we're going to go to Document. Just when you're... Okay, so we're going to go to Document. We're going to go to File. We want to start... do you want to save that? No. Okay, now we're going to do... Okay, so we want lists and spreadsheet. Okay, so we've got a column here, and we're going to put our data into here. So 3, 4, 7, 1, 13, 4, 2, 11, 9, 4, 10. Okay, so this is in column A. And you can also put a little title here if you want. But it's not necessary. Once you've got that in, everybody got it? Yep. We go to menu, and we're going to let's see, statistics, stat calculations. So I'll do that again. So menu, statistics, stat calculations, and then we want one variable statistics. A number of lists, so there's one list, yes. Yep. And it's in list, so our data is all in the A column. Yep. Okay, frequency list 1, and we're going to put the results in column B. Okay, and then we hit OK, and we're getting our information out. So we can see from this, okay, my value of X bar is 6.18. Okay, so X bar, remember, is the mean. So the mean, which is X bar, is 6.18. And remembering, we're giving everything to how many significant figures, Nick? 3. We're also given the sum of the x's. Okay, so this means, well, what does this mean? You should know. Oh, I'm sorry, I've just told you, haven't I? Yeah. It's the sum of the x. So we're basically, this means that we're adding up all the data, okay? And we get 68. This one means what?
You add up the squares.
Yeah, so we're squaring each of these then, and we're adding them up. Now we've also got other information here, whoops, which we will talk about shortly. Where'd it go? Okay, so this SX and this we will talk about later. N is the, nope, the number of data points. Okay, so there's 11 data points. It tells us our minimum value. So the minimum value in our data is 1. Q1, do you remember what Q1 stands for? From, yeah, our first lower quartile is 3. Our median is 4. So we can write that down. And our maximum value is 13. And we'll talk about this as well later. Now, it doesn't give us our mode, but we can just read off that our mode is 4. Okay?
It's never going to give you the mode?
I don't think so. Is that okay?
Yep.
Find the mean, mode, and median of the frequency table. So this is to do with, this one is shoe size, and then we've got frequency. So what does frequency mean?
How many times it occurs?
Yeah, good. How many times it occurs. If we're looking at shoe size, what kind of data is that?
Quantitative.
Yeah, this is a bit of a tricky one actually, because some people say it's discrete, some people say it's continuous, but
It's definitely discrete. It's definitely discrete.
yeah, because it can't take, 3.694, yeah, so we'll say it's discrete. So this is
Yeah.
yeah, I guess, yeah, shoe size isn't. So frequency, so we've got 8 people with a shoe size of 8. We've got 6 people with a shoe size of 9. 9 people with a shoe size of 10. 7 people with a shoe size of 11. 7 people with a shoe size of 12. So first off, let's just make sure we can do this without a calc, but what would the mode be? No. Size 10, because it occurs the most, okay? Size 10 occurs 9 times. If I wanted to work out the mean of this without a calculator, how would you do it?
You would do 8 times 8.
Yep.
Plus 9 times 6.
Good. Yeah, does that all make sense? And then you divide by what? All the frequencies added up. Okay, excellent. Good. If you wanted to work out the median, how would you do it?
I'd subtract 8 from the first one, and then from the, you'd have to just, do it
Almost. We've got, so we'd first work out the total number of data. So we've got 8 plus 6 plus 9 plus 7 plus 7. We've got 37 data points. Okay, so the median is going to be which one?
And then you just know. You simply know.
The 15th, the 17th is?
So we've got 37 points.
Then you count which one's the 17th, which would be.
The median is going to be not the 17th.
You said 18th and a half.
Not the 18th and a half. Let's make it more simple. Let's say I've got one.
Oh, it's going to be the average of the 18th and the 19th.
Nope. Let's imagine I've got 3 data points. The median is which one? The second one, okay? Let's imagine I've got 5 data points. 1, 2, 3, 4, 5. The median is going to be the third one, okay? So what's the relationship?
You round up. Or
add 1 divide by 2. So if I add 1 to 38, sorry, to 37, divide by 2, so it's going to be the 19th data point, okay? So the 19th data point occurs, well, the first 8 are size 8, and then the next 6, so that brings me up to 14. So the median is going to be 10, okay? So that's kind of how you would think about it. But on the calculator, we're going to go back to, I'm recording this good, so we're going to go to our, let's go to a new document again. I want to add lists and spreadsheets. So we're going to use both columns. So I'm going to have 8, 9, 10, 11, and 12. And then we're going to have our frequency, 8, 6, 9, 7, 7. Then we go to our menu, stats, stat calculations, and again it's one variable stats. Okay, so we've got 2 lists. Actually, yeah, maybe just 1 list. Okay, so frequency list. X1 list. Let me just pause it. So I've got my X1 list in A, I've got my frequency list in B.
I have to type the bracket.
Yeah, so and it's square brackets, and then it's going to put my results in C. And we hit OK, and we're getting our results out the same kind of way. We've got our mean value is 9.97.
wait, we go to statistics?
Yep.
And then stat calculations?
Yep.
I can't go up to it. What's going on?
What's wrong? So you're going to menu, stats, stat calculations. One variable stats, 1 list, and it's very annoying. So you your A for your X1 list, and your frequency list is your B. Just to clarify that. And it will give you out everything. Okay. I'll just make sure that you're good with that, Greg. And then it also gives us all the information. We've got our median is 10, and our mean is our X bar, 9.97. Okay, so if you want to practice this, which you should want to practice this, because we're going to move straight on next time, it's on page 289 in the standard level book, just finding the mean, mode, the median. And next we're going to look at the measures of dispersion. Okay, so any questions? Give me a shout.